Hi everyone, welcome to the third lesson for topic 3.1 Bivariate data analysis. So this is also the last lesson that we will discuss about categorical data. So after today's lesson for next week, we are going to look at some of the question so that you have an idea of how the question is going to look like when it comes out in your exam for this topic. All right. So just a reminder for you, if let's say you still haven't got your calculator right, please try to get it within these 2 weeks because after Chinese New Year, then we are moving into the part where we need to do numerical data and TI Inspire is important at that stage. Okay, so you can't use your scientific calculator to help you to solve that. So that's why a reminder, please try to get your calculator before the first lesson after Chinese New Year. All right, so which means try to get it within this week or next week. All right, so let's look at the learning outcome of today's lesson. So you see, it's basically the same thing with the previous lesson, which we need to identify and describe the association between two categorical variables. So you will be using your two-way frequency table or using your stacked column graph. Then after that, we need to know how to describe the association. Okay, so the difference between today's lesson is that we are going to put everything in a nutshell. So which means that you are the one that going to decide which of the percentage that you are using. So either you are using row percentage or you are using column percentage. So we are going to use learn the new terms today, which is the explanatory variable and also the response variable. Okay, so for the description for part, I hope that I can actually discuss with you guys further during the consultation hour. So I will highly encourage you to attend the consultation hour on Friday. All right, so let's move into the recap. All right, on Tuesday lesson, there's a new term that we learn, which called as association. So it's a general term that we use to describe the relationship between two variables. All right, so association is mainly used for categorical data. So that's why you see I didn't put in the word correlation here. So it's good that we try to focus on using this word first. So association. Okay, so first to identify whether there's association or not, there's a useful tool, so which is called as the stack column graph. Stack column graph. And also sometimes when you look at your textbook, they try to use the word proportional column graph. Okay, so they are both the same thing. It's just that given they use a different term, different name here. Okay, to help us to see whether there's an association or not. So if there is an association, meaning that we can observe there's a significant change in the proportion of the variable. Okay, so there's some questions that I received while you're doing some exercise. So please remember that if let's say, okay, let me try to do this. So this is like the idea of it. So if let's say I have these three. Okay, so maybe this one, then this one, and then this one, and then I have. Okay, so when you try to look at it, right, what do you realize? You can realize that they are mostly identical except the first two. I mean, when we try to compare across the column, right? Except the first two proportion, the other three looks the same. So my question is, do you think an association exists here? So can you say that the column, all the proportions are identical? Okay, so you can't do that. So please remember that as long as there's changes that happen when you compare across the column, then we cannot say that they are identical. So the idea is we try to look at it like by using our first sight, I would say that. So when you try to look at it for your first time, right, then you will realize that, hey, this is the difference. It's just that when you try to look into detail, you realize that these three has no difference, when you try to compare to the first two. So that's why this is still considered a significant change. So which means as long as there's a change for the proportion, because there wouldn't be only one change normally. So if let's say there's one significant change for one of the proportion, right? Which means there are at least two. So for example, you can see the first one here and the second one here is actually one increase and a one decrease. Normally that's the idea because your total for each of your column is all 100%, right? If let's say one has a change of increasing, then of course you will have the other one that's decreasing. If let's say all the others stays the same, that's what I mean. So which means that as long as you see there's a significant change for the proportion, then it should be association exists. So which means that the association does not exist for every single proportion, but we wouldn't be able to describe it as there's no association, but we try to describe it as these three stays the same when you try to compare across. So this one increase and this one decrease. Okay, so that's the idea. So we only say that the association does not exist if let's say all of the proportion are really identical and there's no difference that you can tell when you want to compare among the column. Okay, so I hope that you can get the idea, but don't worry, we will actually discuss for that further when we are in the consultation hour. Okay, so today our focus is to look at this part, which is the explanatory variable and response variable. Okay, so sometimes you see the words is slightly long, so that's why when I try to pronounce it, sometimes I'll just use the word EV and also RV. So explanatory variable E and V. Okay, so response variable R and V. So that's why EV and RV. Okay, so when we investigate relationship in bivariate data and in bivariate data, so we will have these two variable, right? So for the two variable, the first one will be called as explanatory variable, or sometimes it's called as independent variable as well. Okay, so independent variable. So the explanatory variable is the variable that you use to explain or you use to predict a difference in the response variable. So this response variable will be called as dependent variable also sometimes. Okay, but we will try to use the word EV and RV much more often compared to independent and dependent. Okay, because that's the words that given in your syllabus. It's just that some of the books they are trying to use this term. All right, so by looking at this word, you can see explanatory variable. So explanatory variable is the one that explain response variable. So response variable is the one that responds to the explanatory variable, right? So same thing when I try to look at this word independent, meaning that it stands by itself. So you have this variable first, then after that, you have the second variable that depends on your independent variable. So that's the idea, okay? So let's try to put it down. So which means the response variable will always response variable will always depends on the explanatory variable. So this is one of the thing that you can try to use when you want to identify the variable. So we can try to apply this when we look at the example later. Okay, so this is some tips to differentiate them. So normally sometimes you'll have the case where you will realize that the two variables seems which one you try to use to explain another one also. I mean both way can work. So what is the questions or what's the thing that I can actually confirm my answer? All right, so this is the three questions that I always ask myself whenever I want to decide explanatory variable. So which variable actually explain the difference of the other? Okay, so that's the first one. So yeah, the variable that explain the difference in another will be called as the explanatory variable. So this explanatory variable, right, is the one that we always use to predict the other. Okay, and the last one, this is very important. So which variable occurs first? All right, so this idea is very important. Later, I'll try to give you an example on that. Okay, so now let's try to look at this simple 5 questions here. So underline the explanatory variable. Okay, so we have test score and also time spent studying. Okay, so you see, you try to ask yourself, among these two, which is the variable that explain the difference in another? Which is the variable that you use to predict another? Or which is the variable that occur first? Okay, So you might ask this. Yeah, so this is a good one to actually explain the third question here. You see, right? By looking at this, then you will realize that isn't it I can always okay. I mean, by using a much more logical idea, we know that the time that you spend in study is going to predict what's your test score. Am I right? Okay, so that's the idea of it. But if let's say you try to think it another way around, right? By looking at your test score, I actually can predict how much time you spend in studying. Is there any problem with this statement? There's nothing wrong as well, right? By having your test score, then I can predict the time that you spend in studying. By looking at the difference test score, I can actually explain the difference of the time that you guys spend in studying. Okay, so that's the idea. So that's why these third questions come in. So which variable occurs first? Which come first before another? So test score and time spent studying, which one actually come first? Obviously, it's going to be the time spent studying. It's because of the it's because of the time spent studying is different, so that's why the test score is different here. So please remember that we do not use the word cost here, okay? So which I wouldn't say that the time that you spend studying costs what you get in your test score. I mean, of course, in some of the terms we can try to illustrate like that, but in this bivariate data analysis, we try don't to judge anything based on this. So which means that, yeah, for example, if let's say you're smart enough, then maybe the time that you spend is lesser, but the test score you still get a very high one. You get what I mean? Yeah. But then in this term, we are just trying to see whether there's an association or not based on like the majority of the people here. So that's why we don't use the word cost here. It's basically the time you spend in study is going to explain the difference, or we can try to use it to roughly predict what's the test score. Okay, so that's the idea. Okay, so same thing number two. So temperature and number of ice cream sold at the store. Okay. So which one come first? Which one that you use to explain the difference of the other one? Then the temperature actually come first, right? Okay, so yeah, I mean, of course, if let's say you want to argue, then the other part you can always say that like when the number of ice cream sold is getting more, then I can actually predict that today is very hot. You get what I mean? Yeah. But then it's actually because of the first one happened first. So it's because of this one happened first, then only the number of ice cream sales become high, right? Yeah, so that's the idea. So I hope that you can see the sequence. So which one comes first and which one comes second. Okay, so the wage and the working hours. So I think this one is very easy, very straightforward. So it's because of the working hour come first, then after that you have your wage, right? Okay, then marital status and film preference. Okay, so this is the idea that you always see. So things like okay, marital status is still okay. So things like age, gender, your height. So yeah, so these are some of the thing it's like from the human's identity, you get what I mean? So it's something that you wouldn't be able to change. So normally when I try to look at like things like age, gender and so on, so they are normally the explanatory variable. Yeah. So for this case, then it will be we want to see whether there's a relationship between these two. So we when we try to compare it, right, then we want to compare whether for single, then for married and so on, is there any difference between their preference in the film, right? So that's the idea. So the explanatory variable, which is the marital status here, whether it's going to affect their preference or not. So that's the idea. Okay, so risk of heart attack and also blood pressure. So you see, this is a one that you can do the other way around as well. So by looking at your risk, then I can predict your blood pressure. You can say something like that. Yeah, but because of ultimately, then we actually have the blood pressure first. And because of your blood pressure is high or low, then that's going to explain the difference in your risk of heart attack. Okay, so that's why I always try to think of these three questions when you try to decide the explanatory variable. So you'll be looking at more example when you try to attempt to the question in your exercise. So yeah, I think by this time, if let's say you don't want to, you don't want to watch the whole video first, then only proceed to your exercise, you can actually solve some of the question in your exercise first. The one that from questions 1 to question 16, which is the one that you need to identify the explanatory variable and also response variable. So you can try to do that first, then check your answer, then only you proceed to the next part of the video. All right, so yeah, let's try to move on to the one that we try to put everything together. Alright, so there's only one example for today's session because it's basically what we have learned before, but I just want to show you the whole flow of the thought process, how you are going to do this if let's say you are not given whether which percentage you need to use, how the whole thought process look like. Alright, then after that we'll do a recap on everything, how are you going to apply it. Okay, so example here, a number of people were asked whether they were in favor of increasing their number of driving hours a learner driver must do before gaining a license. So either they want to increase it, not in favor, or also they were undecided on the issue. Okay, so you have these three category. So the result by the age of the respondent led to the table below. Okay, so you have this table here, which you can try to see this is like their age, and then this is like their preference, either they want to increase the number of hours or not. So this is an example from your textbook as well. Okay, so yeah, when you try to see, then let's try to look at the question. So which is the explanatory variable and which is the response variable? Then you need to draw the table, either showing the row percentage and or column percentage. So you need to decide it by yourself. Then after that, use your table to create the graph. Then we also need to comment whether there's an association or not, then try to describe it. All right, so that's the whole idea for this question. Okay, so first thing that we need to do is decide our EV and RV first. So which one do you think that come first? Yeah, I mean, of course, you can say by looking at this, then I can roughly predict what's their age. Yeah, but in this case, which one come first? Yeah, so like what I say, normally the things that involve like some identity that you can't change, like age, gender, normally that's the explanatory variable. Okay, so in this case, it's the same thing as well. We are interested to investigate whether there's a difference in the preference of whether they want to increase, they not in favor, or they were undecided based on their age group or not, whether the age explain the difference of their decision. So that's why in this case, our explanatory variable will be the age. Okay, so you can just write down here. So EV will be the age. So I think for this question, they didn't give any words. So either you can try to just use the age of the respondent. So if let's say in the future question, if let's say you already know that it's students or what, then you must write down the full thing. Okay, so age of what? Okay, then after that, how about the response variable? Then it will be the other one, right? So we can try to write down they were in favor their preference of increasing, yeah, preference of increasing the number of driving hour. Okay, preference of increasing. Yeah, so every time when you want to write this, right, please try to write as complete as you can, but make sure that it's correct, okay? So preference of increasing number of driving hours. So actually you should write the whole thing, but I mean, it's okay. The driving words. Okay, so yeah, that's the idea. Now part B, draw the table showing either the row or column percentage as appropriate, then use your table to create a proportional column graph. Okay, so yeah, this is very important here because it's a time that you need to decide whether you are going to use row or you are going to use the column. Okay, so we can try to write down here. So this is our EV and then this is our RV, right? Okay, so my question is like this. You remember for the previous lesson when we talk about when we try to draw a stack column graph, right? How is that look like? So this is my stack column graph. So you remember that when you try to which one do you try to put in the subject of your x-axis? Is the one that give you total as 100%. Am I right? Because you are going to create two column which is with the same height, which is the 100% here. So this is why when we try to decide which to use as the subject for the x-axis, we choose the one that is going to give us 100% as a whole. So if let's say row, we are going to do row percentage, which means row percentage, each row is going to give us 100%. So we use the subject of row to be the subject of the stack column graph here. Am I right? Okay, so now try to think of it like this. So it's the same thing. We are going to see, is there any difference uh, on their preference whether they want to increase the number of driving hours or not based on their age. Am I right? So that's why the difference proportion is going to be this. Then this is going to be my 100%. Am I right? Because I'm going to moving across the different age. I'm trying to look at the difference. So that's why the one that I'll try to put in as the subject will be the age 1, age 2, age 3 here. Am I right? All right, so let's try to look at everything in a sequence. Okay, so we have our age as the explanatory variable. So which means that the difference in proportion happen for the number of driving hours based on the different age group. Am I right? So that's why when you try to compare across the age group, which means age group is the one that must be 100%, then only we can try to compare among them. So to make the column to have 100% for each of the age group, then we will need to use the column percentage so that we can get the 100%. So it's the same thing. Since the column is the 100%, so which means the subject of the column is the subject for stack column graph also. So everything is like moving in a flow if you can try to just understand it in this way. Okay, so I hope that you can get the idea. So don't worry, later after this question, then we are going to do a very quick wrap up for everything as well. Okay, so now let's try to move on and to draw the percentage here. So we say that we are going to look at explanatory variable, right? So explanatory variable is the one that is going to be the 100%. Okay, so if let's say you are using, in this case, we are using column percentage, right? So for the row percentage, you doesn't need to have your total. So for this case, you can just try to cancel out everything here. Okay, so or if let's say it's given, then you can just try to write down non-applicable. So it's like NA, 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 but that's fine. So just try to do like this. Okay, so now we try to find the percentage here. So just by finding the total first, then after that we proceed with the next part. So 3 then 30. Okay, I think I can fast forward this part, then you can try to do it by your own as well. All right, let's move on creating the proportional column graph. Okay, so you can see that now you are using column percentage. So each column is the one that is having 100%. So that's why the one that you label as your subject, it should be the subject of your column. So it will be the same thing as well if you try to if you try to look at it in the term where your explanatory variable should be the subject of your stack column graph. So that's why in this term, your explanatory variable is your age. So that should be your subject of your stack column graph. All right, so let's try to do that. So you can try to draw it by yourself. So I'll just fast forward the process as well. All right, so this is our graph. So I think it's quite obvious that there is a clear difference between their proportion here, because you can see the undecided actually increasing all the way from 10% then until 41%. They're not in favor actually decreasing from 80% to 36%. It's like keep on decreasing. Then for the in favor part, it's like increasing up to this point, then increase again. Okay, so this is some of the thing that you want to mention in your description. All right, so let's try to write down the comments as well. Okay, so that's basically the comments. All right. So yeah, for this part, for the description part, we can discuss further into tomorrow's consultation hour for the question that is harder for us to identify. So I guess for this one it's still okay. So basically it's just increase decrease, because for these two it's quite significant lah. So only for this one you can just roughly describe it. All right, so that's the idea. Okay, so now let's try to put everything in a summary, and I just want to just do a wrap up on what's the thing that we need to use, then how to identify the explanatory variable and so on. All right, so this is a part where I want to put everything together, and I try to organize everything in these two tables and try to explain the whole thing that we learned in categorical data. So I hope that after this you can understand it, and I'll encourage you not to memorize but to understand why we do so, because after you understand, right, then everything will become like very easy for you without needing to memorize like what is the situation I need to use this and what is the situation that I want to use it. Okay, but to understand the whole idea. All right. So, but yeah, before I move on here, right, I just want to let you know that when you look at the questions that you will be doing in next week, then you will realize that actually the question is not that general like what you have in your textbook. So which means that it wouldn't be like giving you a set of data, then they ask you to do this, then they ask you to draw graph, then they ask you to write the description. So sometimes it will be much more specific, which means that maybe they try to write some of the percentage here, then you need to find it yourself. or sometimes there are missing columns or missing row in the table, then you need to find the missing data. So it wouldn't be like the whole chunk of thing given to you, then you need to settle everything. Yeah, so you have a better idea on that. So what you are doing in the textbook is for you to have an idea of how to use everything and how to summarize everything, how to identify and how to comment. Okay, so that's the idea. Okay, so now let's try to look at this part. So this is like a very important part. So which one to use, whether it's row percentage or column percentage. Okay, so I hope that you have a rough idea after the example just now. So when we try to answer this question, right, always go back to the objective. Explanatory variable explains response variable. So what we are interested to know is that, is there any difference in the response variable when we try to put the explanatory variable together and we compare across them? Okay, so that's the idea. So you see, if we want to compare across the explanatory variable, then we must make them in the same phase, which means in the same 100%, then only we can try to compare the proportion in between them. You get what I mean? So that's why if let's say the subject of the row is the explanatory variable, so if let's say we have like this, so it means that your EV1, EV2, EV3 is over here. So for us to able to identify the difference in the response variable, we need to make the explanatory variable become in the same phase, which is the 100%. So which means if let's say the row is your explanatory variable, so which means you need to use the row percentage, which give you 100% on your explanatory variable. So that's why for your column, then it will be all non-applicable. Okay, so similarly, if we have our subject of the column is the explanatory variable, so which means that we must put explanatory variable in the same phase, which is the 100%. So that's why we are doing column percentage. So in this case, then all our row percentage will be non-applicable. Okay, so if let's say you want to just remember it, then you can remember it as if row is EV, okay, then use row percentage. Okay, I guess this is straightforward enough. If let's say you do not want to like think of it every time, then just remember row is the EV, so row percentage. So if column is the EV, so then use column percentage. Okay, I guess this is pretty simple. Okay, so now the same thing like what we have mentioned just now. So the stack column is drawn with the explanatory variable being the column. So which means in this case, our explanatory variable is our row, right? So that's why this is like our row percentage. So our row will be the subject of our stack column. So which is, this is EV1, EV2, EV3. So if let's say you do any mistake or in the process, right, you will realize something wrong already, because you imagine if let's say you try to draw RV over here, then you will realize you wouldn't be able to get 100%. Then what happened to your column graph is you wouldn't have all the column with the same height. Okay, so similarly for this one, because the EV is your column now, so that's why the 100% is your column. So this one is the same thing, is your EV1, EV2, EV3. Oops, EV2, EV3. All right, so that's the idea. So one of the things that's very important in this case is that, okay, let me try to write down first. So EV must be 100%. Okay, because if let's say they are not in the same height, then it's impossible for us to compare the difference in the proportion for all the response variable that we have inside the column. Okay, so EV must be 100%. Then the other thing that I want to say is when you try to do description, not comparing within, you are trying to comparing across. Okay, so compare across. So do not do anything that is like comparing in between them. Okay, so you are comparing across. So similarly like this. Okay, so now this is the part where I want to talk about if let's say the question didn't ask you to draw the stack column diagram, then sorry, stack column graph, then how can you actually read your information from the table? Okay, so it's actually very easy. You see, right? After you try to do this, then what happened here is this is your MA, right? Then this become 100%, 100%, 100%. So similarly, this column 1 will become 100%, 100%, 100%. Okay, so one of the efficient way that I'll always encourage the students to do is you try to imagine what happened if you draw a stack column graph. Okay, so you see, when you have this table, right, when you try to draw a stack column graph, how is that going to look like? This is your 100%, right? So if you are drawing your stack column graph, then it will be look like this. So this is like 100%. Am I right? Then you will have these 3 columns. So each EV consisted of 1 column. So this is like 1 graph, 2 graph, and then 3 graph. So your axis is like here. Am I right? Okay, so similarly, what happened when you have this graph? Then which means your 100% is over here, right? So the column that you are having is basically going to look something like this. So your column for EV1, column for EV2, and then column for EV3. Right? Then this is your stack column graph. Then obviously you have all the number here lah. Okay, so how are you going to do the comparison? So go back to what we said here. When you try to, after you have the column, you should compare across. So that's why if let's say you didn't draw the stack column graph, then when you are comparing only the number, so how you are looking at it is based on how's the column look like. So when you're having this kind of column, meaning moving across, meaning that you are reading it from here to here, from here to here. So which means if let's say, okay, let's write an example here. So this is, let's put simple number, maybe 30, 60, and then 10. So this is 10, 10 also, then this is 50, then 40, then this supposed to be 10, 40, then this is 50. Okay, so if let's say I have this, right, so meaning that when I try to move across, then it will be something that looks like this. Because you see, right, imagine that this thing, we are trying to move it doing something like this. Isn't it the thing that we are going to compare is this one, and this one? So this is basically the first one, the second one, and the third one. So that's why you are comparing it. You are not looking at it like this. You are looking at it like this because you are now using the row percentage. So that's why it's important for you to have an idea for if let's say you draw it in terms of stack column graph, how is that going to look like? So you don't move across like this. Okay, so I hope that you get what I mean. So that's why what you can try to do is you try to draw like a stack column graph, then you try to move across. So similarly, if this is a thing that you are going to draw because your 100% is shown here, right? So that's why this is like the column you have when you draw your stack column graph. So move across, meaning that you should compare like this. Okay, so I hope that you have a better idea on this. So basically, this is like the whole thing that how you should use it. So the idea is the same thing for this one. So what you can try to do is you imagine the stack. So imagine stack and also compare across. Okay, so that's the idea when we try to put everything together. So I hope that you can understand. So if not, then yeah, I mean we can discuss further in tomorrow's consultation hour, or you can text me personally, and yeah, I'll reply when I am available. Alright, so that's it for today's lesson. So spend some time to do your homework and understand the content. So you have a better idea, then it will be helpful when we move on to like the exam style question next week. Alright, thanks very much for watching this. So see you in the next session. Thank you.